Tres. Hello, my name is Manuel, and this is a short video where I'm going to demonstrate the MATLAB application I created for modeling the predator-prey dynamics between two populations, the elk and wolves population in the Yellowstone National Park. This project uses a system of differential equations, more specifically the Lotka and Volterra style model, to simulate how these two populations interact over time. I'll walk you through the app, run a couple of simulations, and then explain how to interpret these results. Okay, so this is the main interface of the app. On the top row, we can find the field where you can enter the number of years you want to simulate and the button to run this simulation. On the left, we have the real observed data for elk and wolves represented by bar charts. Finally, on the bottom, we have the model's simulated output elk on the third row and wolves on the fourth row. Okay, so let's start by running a simulation of 30 years. We press the run simulation button. And here we can see the app solves the system of differential equations by using MATLAB OD47 solver. Here we can see the elk population on the upper plot. In the short term, elk generally remain high or slightly increased because of the wolves are just beginning to recover. In the lower plot, wolf numbers increase gradually because their food source, in this case the elves, is abundant. This short-term behavior watches what ecologists observed in Yellowstone right after the wolves were introduced. Now let's run a simulation of 200 years. Okay, here we can see a different pattern. Both of population begin to oscillate over time. This is a classical feature of the predator-prey systems. We can see that the elk grow when the wolves are low, and the wolves grow when the elks are abundant. Wolves eventually overhunt elk, and both populations cycle through rises and declines over time. These oscillations show how predator and prey feedback loops can regulate ecosystem behavior even with simple mathematical models. In summary, this app combines ecological data, different equations, differential equations, and numerical simulation to explore how two interacting species can shape ecosystem dynamics. It's a great sample of how mathematical modeling helps us understand complex systems like Yellowstone. Thank you for watching.